Hi everyone, I'm Mary with Mary Greeley News. Thank you for joining me. I spent 2 days trying to find updated images of Yellowstone Park. Google Earth, all its images are from 2015 and 2016, and I wanted to find images of the tree die-off for the Sour Creek and the Mallard Lake Resurgent Dome. And it's like pulling teeth, and I just couldn't find anything. No satellite views other than maybe cloud cover, different parts of the country through IRIS, etc. Very frustrating. So I felt, well, if it's meant to be, it's meant to be, and if not, yeah, I guess it's not meant to be right now. But as you know, in my last report, I reported how H2s Geyser erupted. Well, evidently, it had been 6 years since its last eruption, which was on January 29th, 2014. And they keep telling us everything there is normal. You'll remember back on September 15th, 2018, when Ear Spring erupted. It was first eruption in 61 years. 259 days, almost 62 years for that hot pool. Yep, a lot of things changed there at the geysers at Norris Junction back in 2018. After being quiet for at least 4 years, Steamboat Geyser came back to life in 2018. In 2019, there was over 48 documented eruptions there at Steamboat Geyser, according to Yellowstone Insider, posted on April 18th of this year. In the time span of 17 years, the Norris Geyser Basin rose over 5 inches, and researchers said it was fueled by deep magma intrusion that fueled the growth. Back on March 30th, 2014, there was a magnitude 4.9 earthquake. And they feel that that earthquake ruptured a reservoir created by the intruded magma. Then of late, I've been talking about the intrusion of magma, as you can see here at Little West Thumb and at Yellowstone Lake, and the frequency of earthquakes. Here we have the monitor. This is Yellowstone Lake. It's up over here by Fishing Bridge, and the earthquakes that have been there along West Thumb, but also recently discovered. This is one of the reasons I wanted to find new satellite images, was because of the area near Turn Lake where fallen trees had died off, fallen on the ground, and turned to charcoal because of the heat coming up from the ground. Because of the lack of updated satellite photos of the area, let me bring this down and show you, it shows 2015. Because of the lack of updated photos, this went unknown, unseen, unheard of until quite recently. In another paper, they concluded that with the use of airborne, spaceborne, remote sensing data sets from 1994 through 2019, last year, they concluded that around the year 2000, a new thermal area started emerging along the northeast side of the Sour Creek Resurgent Dome. Remember, Yellowstone is one of those rare volcanoes, because it's so huge, it's a supervolcano, has 2 resurgent domes. This area, this article says, initially covered by healthy forests and characterized by increasing area of vegetation, stress and mortality, and an increase in radiant heat output. Vegetation stress was the first remotely detected sign that the area was changing, even though surface heating probably preceded or accompanied this process. They don't know. They weren't taking thermal images. During field work in August 2019, they observed it to be dry, steam-heated, acid sulfate thermal area with a northeast trending arch-shaped zone of bright hydrothermically altered soil, and heated ground with surface temperatures from 60 to 80 Celsius, which is 140 to 176 degrees Fahrenheit, a boiling point, 93 Celsius to 200 degrees Fahrenheit, just below the surface, and several steaming fumaroles, and a large tree kill zone, 33,300 meters to the power of 2, in the area, with fallen trees that were carbonized, turned to charcoal, where they were in contact with the warmest ground. This new thermal area is the largest one that has ever been observed from the onset through 20 years of evolution. But they also observed younger, less than 5-year-old trees regrowing in the cooler zones within the area of the fallen trees. So either those trees have not as deep roots, or the area is finally cooling down. They just don't know. It says here, to our knowledge, no report about gas emissions from this new area have been documented other than smelling H2s gas from the area doing field work. H2s is hydrogen sulfide. It's a colorless, flammable, extremely hazardous gas with a rotten egg smell. Some common names for the gas include sewer gas, stink damp swamp gas, and manure gas. Here it says hydrogen sulfide is heavier than air and may travel along the ground. It collects in low-lying and enclosed, poorly ventilated areas, such as basement, manholes, sewer lines, underground telephone pole vaults, and manure pits. Health effects. Chemical asphyxiant. Yeah, you can suffocate from this stuff. Burning of the eyes, cough, shortness of breath, prolonged exposure may cause eye inflammation, headaches, fatigue, irritability, insomnia, digestive disturbance, and weight loss. It can also cause accumulation of fluid in the lungs, dizziness, nausea, vomiting, staggering, excitability. I've talked about the tree die-off that you can see, and it seems to be increasing here at the Mallard Lake Resurgent Dome that you see on the live web camera. Using Google Earth, here is the Mallard Lake Resurgent Dome, and over here to the north is the area of recent earthquakes. And from this image that is dated 2015 on Google Earth, you notice all these earthquakes in an area of dead and dying trees. I tried to find out what the name of this one pool was, but I couldn't find it, and I spent too much time trying to find updated images to compare the die-off to recent times, satellite images, but I couldn't. There was a paper that I found many years ago, and it talked about the magma that's coming from the Mallard Lake Resurgent Dome, and like a dam or a wall under the ground that is preventing the movement of the magma basically along the Firehole River. Now, if you look at the live image of the camera, you'll notice that the Firehole River actually does, by looking at it, act as a dam. We got uplift on the eastern side, the northern side of the Firehole River. That's very clear to see. You got the uplift going on. Right over here, if they would zoom in, which is just starting to steam right now, is Giantness, the one that recently erupted after the 7 years of being quiet. Also in the same area, right over here by the boardwalk, is the new thermal area that damaged the boardwalk. It had to be repaired. That's a brand new thermal area. And then up over here, I follow these trees, is Ear Spring, and that's the other one that erupted after a 70-year quiet period. Then I found another paper from geosociety.org that showed areas in pink of a hypothesized foci of future volcanism in relation to the main national park infrastructure, roads and surrounding towns. Then they got in yellow, Norris Mammoth Corridor, possible small volume of rhyolite and basaltic eruptions. Let me pull this up for you. And then in green, the Minor Plateau Fault Zone, possible basalt eruptions. Number 2 and number 3 cover West Thumb and the area of the other dome, the Sour Creek Resurgent Dome. In a paper published back in 2007, it says at least 26 hydrothermal explosions have been documented in the 126-year historic record of the national park, and others undoubtedly have escaped observation. At least 18 large hydrothermal explosions have formed craters wider than 100 meters. Conservatively, at least one rock-hurling explosion every 2 years is estimated to occur at Yellowstone. But because most of these events are small and usually occur when few visitors are present, the likelihood of harm to park visitors is relatively small. The average reoccurrence of an explosion that could cause personal injury is probably between 10 and 100 years. An average reoccurrence time of an explosion large enough to produce a 100-meter diameter crater is probably about 200 years. But such an event could expel rocks and other hot debris more than 2 kilometers from the explosion site. Most hydrothermal explosion craters at Yellowstone are at the Firehole River, Geyser Basin beneath or around the Yellowstone Lake, and in the southern part of the Norris Mammoth Corridor. In addition to hydrothermal explosions, toxic gases, mainly carbon dioxide and hydrogen sulfide, pose hazards. Concentration of these gases in the atmosphere are generally low at Yellowstone, but they can build up in confined areas such as valleys, caves, tunnels, especially during the windless conditions. Remember all the buffalo, that small herd of buffalo that they found that dropped dead from the gases recently? Most areas with toxic gas hazards can be kept off limits to people, but gas emissions should be continued to be monitored, and they're not doing that. They have to send someone out to test it because they don't have any live monitors anywhere in the park to test these gases. Then it goes into the lava eruptions. It says here that the basalt lava. The average period between basalt eruptions at Yellowstone region since its formation of the Yellowstone caldera have been about every 16,000 years. Large rhyolite lava flows, many having volumes greater than 10 kilometers to the power of 3, have erupted within the Yellowstone caldera during the past 170,000 years. Initially, these larger eruptions were preceded by explosively ejected pumice and ash. Subsequent lava excursions could last for many years, covering areas greater than 350 to 400 kilometers, to the thickness of tens or hundreds of meters, and the volumes of 5 to more than 50 kilometers. Available data suggests a highly exodic behavior of past eruptions of this sort of period of a few thousand years, characterized by the numerous eruptions being separated by longer intervals of about 12,000 to 38,000 years without eruption. So they think an average eruption happens about every 20,000 years, taking the data that they have. Viscous rhyolite lava would advance much more slowly than a basalt flow. Most affected facilities could be safely evacuated and perhaps relocated. The average reoccurrence period of small rhyolite eruptions in the Yellowstone Plateau field is about every 50,000 years. I would say it's overdue. In addition to the primary hazard posed by any future eruption of basalt or a small or larger rhyolite lava eruption. Important possible secondary consequences include inland fires, debris flow, and floods triggered by the displacement of surface drainage by lava. And then it goes on about, given the ongoing YVO monitoring program, it is likely that there would be recognizable premonitory indicators of any impending basalt eruption. Talking about basalt, not rhyolite. But in particular, multiple shallow earthquake swarms, focused in small, probably linear area, would be likely to be followed or accompanied by volcanic tremor. But because YVO deformation monitoring is focused on the Yellowstone caldera, initially uplift associated with the shallow intrusion of basalt magma perennial to the caldera might not be recognized quickly. The emission of magmatic gases to the surface would be a major indicator of impending eruptive activity, but might be quite difficult to recognize in the presence of Yellowstone's massive hydrothermal system, which tends to scrub out magnetic gases passing through it. Nevertheless, any locally increased emissions of CO2 or H2s should be monitored, and they're not doing that. Only when they send someone out with a bottle to gather the gases, the water, got to take it back to the lab, etc. Here it is, 2020, and they have the technology to monitor these gases 24 hours a day, 7 days a week, second by second, and they have not deployed that technology to Yellowstone. Now again, this is a dated paper, and it says here, any appearance of SO2, which they do have now, they know they have sulfur dioxide there at the park, presently absent at Yellowstone, would be especially indicative that the hydrothermal system was becoming dried out by shallow magmatic intrusion. Here in this paper, it says sulfur dioxide, SO2, is released from a volcano when magma is relatively near the surface, if SO2 is detected at a non-erupting volcano. It could be a sign that it will erupt soon. By monitoring the amount of SO2 being emitted from an active volcano, it is possible to calculate the amount of magma that is supplying the eruption. However, SO2 easily dissolves in water. So if the volcano has abundant surface or subsurface water, such as a hydrothermal system, it becomes difficult and sometimes impossible to determine how much sulfur dioxide is actually being released. So here we have SO4 and 2, and I want to explain this. These are the different name. It's all sulfite, and we got sulfite 2, etc. So it's all one and the same. Here it says 2 coordinate bonds with 2 oxygen atoms and 2 double bonds are formed with oxygen after sulfur expands its variant shell. So when I go to this Excel document that I found, Yellowstone River at Corwin Springs, Montana, and Duke Hot Springs on the Miller property, and we got SO4-2, and we got the year 2002, 2003, 2004, 2005. I guess these are the different areas where it was taken from. 2006, 2007. I'm going to pull this over and you can see the other numbers. 2008. 2009, 2010. I guess that's as far back as it goes. And I got that from this page, which allowed me to download it. Between 1983 and 2001, only Cl concentration and fluxes were determined. But starting in the water year of 2002, the concentration and fluxes of other anions of possible magnetic origin, and here we got it, possible magnetic origin, HCO3, So4-2 were also determined. And several new sampling sites were established. Horowitz document in 2007, the ongoing sampling and analysis of river solute flux is a key component of the current monitoring program of YVO and the collaboration between USGS and Yellowstone National Park. And then it goes down into about how they were gathering samples once per month between November and February, every 2 weeks on March and April, and August, September, and October, once a week between May and July, for a total of 28 samples per year for each river. However, the actual number of collection samples is less in many cases. Samples are collected at or close to USGS stream gauge sites. So they're gathering this information from rivers and streams, and we know that if they do that, it's going to be diluted. And here's that MS Excel file I said that you can download. Anyways, that's all I have for you right now. Any thoughts or comments or questions, please put it down below. Thank you for watching. Thank you for your support. Please stay safe. And I will talk to you later. God bless y'all.